Hello, my name is Jenny Frank. I'm a PhD student at SUNY ESF studying sustainable energy, and I'm presenting my research, quantifying the comparative value of carbon abatement scenarios over different investment timing scenarios. And what this basically means is that we calculated both the financial and greenhouse gas emissions impacts of investing in a currently mature and commercialized biomass-based diesel pathway versus investing in a not yet fully commercialized and immature battery electric pathway for Class 8 heavy-duty vehicles. Our study objectives were to calculate the comparative impact of investing in these different scenarios for Class 8 heavy-duty fuel systems, and we looked at 4 different scenarios: a 100% petroleum diesel scenario, a biomass-based diesel scenario, and then 2 scenarios that take into account investment timing, so petroleum diesel to battery electric, and a biomass-based diesel to battery electric scenario. We calculated the 20-year net present value, including financial costs and benefits, as well as the social cost of carbon. And the social cost of carbon is the cost of emitting 1 megagram of carbon dioxide equivalent. And to calculate this, we subtracted the annual emissions production of each comparative scenario from the annual emissions production of the baseline diesel, so the petroleum diesel scenario. And we multiplied that value by the social cost of carbon. As for the results, Scenario 2 achieved the highest net present value, which was the biomass-based diesel scenario. And Scenario 3 achieved the lowest net present value, the petroleum diesel to battery electric scenario. In terms of cumulative emissions generated, Scenario 1, the petroleum diesel, accounted for the highest cumulative emissions, whereas Scenario 4, the biomass-based diesel to battery electric scenario accounted for the lowest cumulative emissions generated. In terms of the cumulative social cost of carbon benefit, the highest benefit was achieved for Scenario 4, the biomass-based diesel to battery electric scenario, and the lowest benefit was achieved for Scenario 1, the petroleum diesel scenario. So in conclusion, this study really highlights the significance of accounting for investment timing when you're looking at both the financial viability and the greenhouse gas emissions production of different decarbonization scenarios. And it also shows that when investment timing is considered, those scenarios that yield the highest annual greenhouse gas emissions reduction benefits do not always account for the largest net present value. And the study finds that the biomass-based diesel to battery electric scenario achieved the largest cumulative social cost of carbon benefit, and the biomass-based diesel scenario achieved the largest 20-year net present value. And this is very important for researchers, policymakers, and other interested stakeholders, because both sides must be considered, both sides in terms of investing now in a currently mature and commercialized carbon abatement pathway, such as the biomass-based diesel pathway, versus investing later in a lower carbon pathway that has yet to reach commercialization, such as the battery electric pathway for heavy-duty trucks. So I want to thank you for listening, and I also want to thank the National Biodiesel Board for funding this project, and to all the co-authors for providing their support and technical expertise.